So the topic for today, RFC types. Okay, not the RFC connection types here. This is the RFC types here. So types of RFCs. So types of RFC here. So what is this mean by types of RFCs concept in SAP here, right? So RFC, remote function call. Remotely, you can uh, we can transfer the data from one system to another system here. So RFC is a mechanism that allows business applications to communicate or exchange the information from other systems, one system to another system. To exchange the information, we need to use the RFC function call. We will use it here. So it consists of two. One is the RFC connection calling interface to the above programs and non-SAP programs. Mean third-party systems also we can connect it using the RFCs here, right? So normally SAP side. So sometimes in our landscape, suppose if you are the ECC, we need to send the data to the ECC system, real-time data to the BW system for the reporting purpose, and also we need to send the data to the CRM systems, and also we need to send the data to the supply chain management. So like that, so the R3 data we have to send to the BW, then BW data we have to send it to the CRM, right? Then also SCM, right? And also there are the multiple products we will do it here, right? This is a real-time system. This real-time data, it's required the data to the BW system for the analytical purpose. BW system is it's one of the warehouse management system. Warehousing purpose, we will send the data to the analytical system. Then this system data we require to the ECC system, and this system data we require to the SCM system, right? Then SCM RT data we require data to the CRM system. Then CRM it's required the data back to the ECC system. Then there the to and flow the connections are required. Here main thing is the ECC is the main system, critical system here. All the transactions, real-time transactions will happen to the here. The data, whatever the inserted into the ECC system, it will be pulled by the other systems via RFC destinations, via RFC connections. It will exchange the data or information to the system here. So RFC is a SAP protocol to handle the communication between the systems, to communication between the system, to exchange the information or to exchange the data. It's required the communication here, right? So here we must know SAP uses the CPIC protocol. SAP in the between system to system, it will use the CPIC protocol. CPIC protocol, TCP/IP, HTTP protocol. Normally in the browser, how we are using the HTTP protocol to log into the sites, TCP/IP, right? And so then CPIC is the one of the protocol. It will use to transfer the data between the SAP systems here. Data between the SAP system. This is a SAP specific protocol. So the communication based upon the CPIC based communication will happen here, right? So that is the main thing here. Special routing instructions that will happen in the here. So this RFC helps to reduce the efforts of the programmers and avoid the redeployment of the methods, communications, and everything here, right? It convert the data into the format, understandable format by the remote system here. Suppose sir, this is the one system behavior, this behavior is different. How this will exchange the data? So it will convert the data, which is understandable format by the remote system. It will convert the data here, right? So there the types of RFCs are there in SAP here. Types of RFCs here. So one is the synchronous RFC. There are the four types of are there. One is the synchronous RFC. Second one is the async RFC. The third one is the transactional RFC, TRFC. Normally we will call it as the TRFC, transactional. So transactional RFC. The fourth one is called the queued RFC. Q RFC. So that there are the four types of RFCs are there here. So sync and async will be internal mechanisms here. it will internal mechanisms. We don't have any transaction codes for the sync and async transaction code here. So synchronous RFC means here, what is that synchronous RFC means? So requires both the systems. When you are transferring the data to the one system to another system, it requires both the system to be available at the same time to communicate the data, to transfer the data. It is the most common type which is required immediately after the execution of the immediately it is required here. It's communication between required here. So when the sending the first data to the first table data, it is sending to the secondary, then means our target system, then it will send the acknowledgement back to the primary means your EC source, saying that, oh, I received the transaction. Then immediately it will send the second data to the here, then it will send the acknowledgement back to the here, then it will send the transaction to here, which means here, so here the source is required the acknowledgement from the your big target system here. Then only it will send the other data. And also this type of communication mainly for communicating the data between two systems. Once both the systems at the same time should be available here. It will be available here, right? So here the acknowledgement is required here. Right? Suppose example communication between the systems, RFC communication, and also the remote client copy when you are doing both the time, same system should be available here. And also web application server to GUI to SAP application server. So this type of synchronous application should be required. Synchronous communication is required here, right? Otherwise, so otherwise it will not send the data to the this target system until you receive the acknowledgement from the secondary means BW system or target system here. So this type of communication is called the synchronous RFC here. Okay, synchronous RFC means example. I will send you the one example. I will tell you the one example here. So suppose in the old method, in the old we have nowadays we have the smartphones, right? In the old we have, I see we have the in the old the not in the touchpad mobiles, not in the smart mobiles. There is a delivered option. We will get it out, right? When you are sending the message to your friend, text message to your friend, as soon as your friend receive the message, immediately you will get the one acknowledgement back to your mobile saying that delivered something like that. One beep you will get delivered something like that. One beep you will get, right? So which means then you can assume, okay, it's delivered to their friend. Again, you will send that second message, third message. Then each and every message, each and every one beep you will get, like one beep sound you will get, like delivered something like that. You will get the acknowledgement back from your target, your friend to your mobile. That communication is called the so that communication is called the so synchronous communication here. So when it comes to the asynchronous communication, so where acknowledgements are not required. Acknowledgement is not required here, similar to the postcard delivery example. So in the asynchronous communication, acknowledgement is not required here. Means the source continuously it will sending the data to the target, but it does not wait for the so whether my target is received or not. It does not require both the system to be available at the same time in execution. Means the result is not immediately required sent back to the calling system here, right? So source system does not wait for the target system to deliver the message or data without taking any assignment. This is not the reliable communication since data may be lost in case of target system is not available. So data may be lost, right? So that's why the async communication is not reliable communication here. But because keep on sending the messages to you, I'm not sure whether you are receiving or not. I'm keep on sending the messages. Sometimes the messages may be delayed. The messages is not the reliable communication, right? If I send the first message, you will send the I will get the acknowledgement back saying that you are received. Then again I will send the second. Again I will send the third, fourth, fifth, something like that here. Then so keep on sending the messages. Then you will get the this type of things, right? So that is the one thing we got it here, right? That is the so types of RFC methods we have here. So source to target, we are sending the data to the source to target here, right? So this type of communication we have, this is called the asynchronous communication, right? Means it does not wait for the acknowledgement from the side. Similar kind postcard delivery. So I'm sending the postcard delivery to you. So then after some days, after some hours, I'm not sure whether you receive or not, just I'm sending the postcard delivery. Signed off. This is called the results are not immediately. Results are not immediately here, right? So that is the asynchronous communication here, asynchronous communication here. So which means source means ECC does not wait for the target BW system, whether does they deliver the message or so whether they are received or not, it does not wait. Immediately keep on sending the data to the target. That's it. That is that type of communication is called the asynchronous communication. Synchronous, it will wait for the acknowledgement from the target. So async, it does not wait for the acknowledgement. That is the main thing here. Then transactional RFC. So what is this transactional RFC? Right? So transactional RFC is a special mechanism. It is a, it ensures it will is for each and every transaction when you are sending to the target, it will assign the one transaction ID. When you are sending the transactional RFC is a special form of the special mechanism. So which means when you are sending the data from source to target, then it will assign the one transaction ID for the each and every transaction. So it will ensure that you will not target will not receive the duplicate transactions from the source here, right? So the transactional RFC. We can see the transactional RFC in the SM58 is the transaction code. There we can see the transactional RFC here, right? So there we can see the transactional RFCs are failed or processing or not. We can see it here. So which means so due to remote system may not be available at the same time of when you are sending the data to the target here, right? Even though remote system is not available, your transactions will get stuck here. As soon as the remote system means your target system is available, then immediately it will send the transaction to the target system here, right? So even though if the target is received the similar kind of transaction, that is a duplicate data, then that will be detected in the SM58 transaction code here. We can see the transactional RFCs, all the transaction RFCs in the SM58 transaction code here, SM58 transaction code here, right? So for everything in the real time, we may get the lot of things here. So every transaction, you can see the transaction ID, right? Transaction ID which is going to the target here, right? So those kind of things we can see it in the SM58 transactional RFC. In case of if we find the something got stuck in the source target, then we can try to reprocess, execute the LUW. Then even though it's giving the error, then we can inform to the user. Caller means user or the related functional team, so that they will take care of the regarding this format data format issue or not, what is that exact error. So they will take care of this communication, right? So transactional RFC is a, it's the same kind of asynchronous communication method only, but it will assign the one transaction ID to each and every transaction. When the multiple data you are sending multiple times, you are sending the data due to some network issues, you are sending the data to the target with the same data already available in the target, it will say like it's a duplicate data, means it will avoid the duplicates, it will avoid the duplicates here, right? So it will assign the it assign the transaction ID to the, it will assign the transaction ID. So it does not wait for the target system to be available. Similar to the registered post. This is the postcard delivery. Postcard delivery. The async is the postcard delivery method, right? Postcard delivery. But the transactional RFC is like a, so it's kind of a transactional RFC is like of a registered post, right? So you know what is mean by registered post, right? So maybe you can understand the registered post here. So it will target is not available. then it will wait. As soon as it is available, it will send the data to the target. But each and every transaction, it will assign the one transaction ID to the target. In SM58, we can monitor so these transactions and everything, we can monitor it in the systems. Okay. The next one is called the queued RFC, right? Only transactional RFC, we have the transaction code to monitor it here. Remaining async and asynchronous are the internal communication methods. So it will use it based upon the situation. It will use the internal mechanisms here. And queued RFC. Queue means queue via order wise, sequence wise. It will send the data here. QRFC. QRFC means so it is a mechanism of so it is guaranteed it is mechanism of queue wise, order wise, sequence wise. It will processing the transactions in a sequence. In a sequence. In a sequence wise, it will it will process the transactions here. So it is recommended if you want to guarantee the several transactions are processing in the predefined order. So then we can use the queued RFC here. Queued RFC processing the transaction in a sequence. So that is called the predefined order. Whatever the you order you define it in the predefined order wise, it will transfer the data here. It will transfer the data here. Predefined order here, right? So that is the queued RFC here. So for this queued RFC, which means suppose they are the queues, they are the two types of queues in the SAP here. One is called the outbound queues, outbound and inbound queues, outbound and inbound. You are outbound, out. You are going out. Inbound means you are getting down from bus. Outbound means you are going inside of the bus, getting out, getting onboarded or offboarded, onboarded and offboarded. Okay. So inbound and outbound. So when you are example here, so here, suppose example you see here, this is the source, this is the target here, right? So you are sending the data to so source here. There is a free sequence, there is a predefined order here. So this is called the outbound. This will go to the outbound here. This will go to the sorry, this is the outbound. This will go to this system, and from here to outbound to the in this system we have the inbound. This system has the inbound here, and the data will comes to here, the data, and this is called the outbound here. Data comes to the here, and in the system it will insert the some records, then it will go to the again outbound here, then from here it will go to the again via RFC destination, it will come back to the same status here, same step. It will come back to the same step here, same. It will come back to the same system. It will come back to the here, right? Which means see how the data flow is happening from one system to another system here, how the data flow is happening from one system to another system here. So this is the so out. So which means it is coming to the inside of the system here, right? This is called the inbound here again. So this is the ind, which is coming inside of the system. This is called coming to the outbound. This is called the outbound here. Every system there is a inbound and outbounds are there here, right? Every bus there is a inbound and outbound entries, right? Normally some buses in and out is only one, or some buses we have the in and out is different, right? So normally inbound communication, inbound, so outbound, right? So data, there is a transaction happened by the user here in the system. So this transaction has to go to the BW system in a order, in a predefined order, in a queue that has to move to the target system inbound. That is called means which is going out, and another system which is coming inbound. Then here some records or something will be inserted. Then again it will go to the out. Then again it will come to the order like this one. So this is a business flow, inbound and outbound here. So here In SMQ, in SMQ2, we can see the inbound queues here. In SMQ2, we can see is there any inbound queues are stuck or not? We can see it here. SMQ1, SMQ2, we can check the inbound queues here. SMQ2 is the transaction code. We can check the inbound here. So then outbound, we can check it in the SMQ1. SMQ1 is the transaction code. We can check the SMQ1 here. So data is moving from one system to another system. Then we want to check whether really data flowing is happening in my system, or is there any data getting stuck here. We can see it here. So we can see the entries. Nothing is selected currently. But in the real time, we may see the lot of transactions will be stuck here. So then we need to reprogress or so then we need to inform to the respective team to correct the data and everything. They will take care of that one here. So here SMQ1 is called the outbound queue, which is going outside of the system here, outside of the system, right? SMQ1. So then the same data, when it comes to the other system, then it will come to the other system. How it will send? Via RFC destinations. Or where to configure these queues and inbound queues and outbound queues means in SMQR is the transaction code R in scheduler, which is coming inside of the system. So inside of the system, which is coming means via queues. Which queues it will order it here. Suppose like, so the functional team will define there are some queues will be defined XB, XA star, something like that. They will define the queues here, right? They will define the XBT, something like that star queues. They will define it here. Then the queues will be created in this case here. Queues creation, we have to do it in the inbound queues. This is the inbound queues, SMQR. We can create it here. QS, out, which is going outside of the system. Out means how it will go to the outside of the system via RFC destination. See, then immediately we need to create the, okay, via RFC destination, we need to transfer the data here. Then one more entry you can create like via RFC destination, we need to transfer the data. So queues, queue wise, destinations wise data will be go here, right? Out, queue out scheduler, queue out. Out means so Q1, so SMQR, right? SMQR, SMQS are the QR, SMQS. S means out, outbound queues creation. This is the queues creation here. So QR means inbound queues creation here. Inbound queues creation, we can do it. But where can we monitor whether the data is going or not? Q1, Q2. Q1 and Q2, we can monitor whether the data is moving or not. In the SMQ1, we can see the data, whether the any data got stuck or not. Currently, we don't have much data. That's why there is nothing is stuck here. But in the real time, definitely there is a stuck entries. Definitely the data will be stuck here in the real time, right? So QR inbound, right? QR. So inbound here, which is means inbound. So if the data is coming to the inside of the system means order wise it will come and order wise it will process here. Predefined order. Who will define the order? Who will create this? All these things means your functional team. Your functional team will create this order and everything. They will take care of this part here, right? So then, but our duty is here, if they ask us to create the queue, then we will go for the registration. Then whatever the number, whatever the queue, they will give it here. So some ABC, then that queue we can define it here. That queue we will define it here. Whatever the number they asking us to do, we will create it here, right? So here the queues, the order creation, we have to perform it in the here in this case here, right? Then here SMQS. So yes means outbound scheduler, out creations. Out means via destination it will go to the ECP system, ECD systems, NW1 systems and everything, right? Suppose I want to send the data to the NW system, but via order wise I want to send it to the NW1 system here. Then I can add the NW1 destination here. Then this will connect to the destination. Then via destination, the data flow will happen here inside of the system, right? So like that, I can add the entries here, right? So based upon this destination, the data flow will happen, right? So where can I check whether the data flow is happening or not? That is only for the registration purpose. But to monitor this one, daily we need to go to the SMQ1 outbound queues to check are there any entries got stuck which is going outside of the system. Then we need to check it out. If something failed, we need to reprocess something. Otherwise, we can so inform to the functional team. This is our regular basis duty here. SMQS and SMQ1 and SMQ2 are the regular one which we have to check it out in the systems. Okay. So this is the queues. There are the types of queues are there here. SMQ1 and SMQ2 here. So this is the one. Okay. Only real time SM58 we will monitor. Q1, Q2 we will use to monitor the data fluctuating is happening. Sometimes during the upgrade time, the people will ask you to, so please stop the data flow from one system to another system. Please stop the data flow. Then in this case, you can go to the QR, then select the all the queues here. Maybe if you want to select the all the queues, otherwise you can just use the select all, then deregister, then it will come to the U. Then data will not go outside of the system here. Then select all, then registration, then data will come to the, so will come to the your online status here. So if the queues are stopped status, then data flow will not happen to the respective target systems here. Data will stuck in your system only. If the queues are happened, then it will go here. Same as like here, the QS also here, QS and QR. So data deregistration, registration here, right? Deregistration and registration, we can do it here. So registration. So select all, deregistration, registration. So normally during the upgrade time, so that time we will, during the outages time, we will stop the queues so that the data flow will not happen. If you don't stop it, what will happen? So if you stop the system, data flow, you are not stopped it here. Data, this flow is the continuous cycle. This is the continuous cycle procedure, always. So continuous cycle here, right? That is the system. Server means what? System is means once. So if you do the transaction here, it will be inserted here, it will go to the some other system, and the transactions will happen, that will send the acknowledgement back to the here, the payments, then again a ticket will be booked here, right? That is the transactions here, right? Only within the system means you cannot do anything. You need to link to the other several other systems, peripheral systems. You need to talk to the some other systems as well. So in that case, suppose this is the server, you are trying to book the ticket, train ticket. But the train ticket, when you're booking it here, then it is via payment gateway. It will go to the some banking servers. This is the banking server. In the banking server, you will do the some in the banking server. What you do in banking server, you will enter all the details and everything. Once everything is done, the transaction is done, the payment is done. Again, the banking server will send the acknowledgement back to the your main server saying that, so okay, transaction is done. Go ahead and book the ticket. Then it will book the tickets. So like that, the transactions will happen here, right? So it will happen, the continuous cycle. This is a continuous cycle here, right? So that is the types of everything will use the RFC only, remote function call only, to communicate from one system to other systems, right? So this is the types of RFCs and the queue mechanism in the SAP system side here. Okay. Any questions, anyone?
Just one, Ravi, but this is regarding client copy. Is it possible to set up like a, or maybe there's another method of doing this, but can you schedule a client copy like background job to take place every day or every week kind of thing to update those tables?
Every day client copy is actually 1 or 2 times activity. If you schedule it every day, yeah, we can schedule it. We can schedule as a background job, but yeah, now whatever you are doing the client copy, you are scheduling as a background job, right?
Mm-hmm. No, as
So
in
why?
like I guess not in that sense, but more of how do you constantly like update data from some say like dev to QA environment or from QA to prod?
Transports, transports.
Okay.
There is a one concept is called the transports. This is the client copy, means entire client data one time you are transferring to the source to target. Then after that, whatever the new development will happen here. So as a request, that request will transfer to the target system. Same data will be inserted here on top of the existing data. So transport request is the mechanism. That is our next topic only actually. So
Okay.
this is the source. This is the target system here, right? So this is the target, we have the client, and source, we have the client. If you do the client copy, what will happen? It's a one-time activity. So if the small databases, it will take several hours. If the large database, it will take days. Then it will transfer the data. But I don't want to always do the deletion from the source to target and again insert the record. It is time taking process here. I want I want whatever the new developments. Now both are in the sync. Source and target are in the sync. Why? Because you've done the first client copy. The base data got received it here. That is fine. Now tomorrow, if the my developers always will do the develop the new customization, then that customization I want to transfer to the target. Then via request, there is a concept is called the via transport request. Via transport request. So they will transfer the data to here. Only whatever the data they have developed, only that data they will transfer to the target here via request. Then, so only that data will be inserted. Nothing will happen to the already existing data. But in case of client copies, so existing data will be deleted. Then whatever the data is there here, it will be copied. So, so client copy and the transport request both are two different here. This is only just insert the records on top of existing data. But client copy, it will delete the entire client data will be deleted. So this is a dangerous option. Only one or two cases, maybe so during the system build time only we will perform the client copies, not all the times here. Only during the system build only, when you are creating the new client, that time only we will copy the data. Otherwise, so then remaining all the times every day, daily, maybe multiple transport requests we may have to import into the target system here. So that is the concept we have to use it here.
Yeah, that makes sense. So if you are doing like, I guess what I'm also trying to understand is if there's any changes made to like one system and you want to get those changes over, um, whatever like new changes happen, for example, is there a job that can handle something like that, or is that something? Is there like a concept of that that's set up that handles like every say couple of days, or maybe if there's a change, the other system recognizes it and just pulls the data kind of thing?
Yeah, that one we can create as a background job to transport the changes to the target, or we can also manually also we can do that one. But sometimes what happens if you create the background job, automatically it will transfer all the data to the target, whatever the changes are recorded, right? But sometimes what happens, they will do the changes, but that change will not be moved to the target. It is not completed. They should not move to the target. Then in that case, that change also will move to the target. So the background job, whatever they recorded, all the requests will be moved to the target. That is not the case. I want manually move to the target. Then we need to test it out. In that case, so we have to use the manual export and import, manual transport request import procedure. We have to do that one. So this concept will come in the STMS. There is a STMS concept, transport management system, to move the changes from one system to another system via request. So that concept will come. Exactly your thing will come in this concept.
Okay, thank you.
Any questions, anyone?
Did you get the ECD system up? Or is that loggable
Yeah,
now?
it's opening now. Yeah, I copied the data, right? Yeah, ECD system. I'm in the 100 client. Let's go to the basis and yeah, it's opening now. I copied the data, right? It's opening. Yeah, NWD also opening. Mm, and we have S4 system also opening. but don't log in now for now. There is a high priority loads are running here. Just note today only the conversion got completed for this system. So there the high priority loads are running in this system. So that maybe max tomorrow this will be available. So you can also get practice on this system as well, high priority systems. So their loads are running already full. System is already full here. Yes, sir. Okay, it is running. We need to do the adjustments and everything. Same as for any system, our common procedures here. Okay, so that's it for today. So tomorrow is Saturday. We will connect it and we will discuss about the and yeah. First of all, first 30 minutes tomorrow plan question and hours you have to explain. So then we will go for the one of the small topic for tomorrow. Okay. Thanks, guys. Thank you.